Okay. Welcome everybody, registrants and especially attendees for being here with me. Today's webinar is about the use of big data in graduate and professional research. As computers, internet, and social media are increasing their influence in our daily life, the amount of available information is also increasing. And therefore, the sources for studying trends and patterns of human and nature behavior are bigger and more complex. How can we research real-life problems of our uncertain and interconnected world? By means of big data. Please remember that under the handout tab, you have the presentation and you can download it. To people who register, that presentation, and of course to the attendees too, that presentation will be sent. Erika says, I have another live conference, so apology for not being able to attend tonight. We'll watch recording. No problem, Erika, no problem. And welcome, Jemine and John. Okay, let's go, as usual, to a quote. As this quote states, the ultimate goal of gathering and analyzing data is to use its information to solve problems and improve life. Data by itself is useless. An analysis without action is a waste of time and effort. Commitment to use results to improve situation is a must when dealing with data. Welcome, Ajesha. So, big data is a big theme to discuss in a short webinar. However, my goal is to provide you a basic but useful understanding of it. To achieve that goal, I have set up this agenda. As I usually do, I begin presenting the concept. In this case, what is big data? Its importance, and when it is a good idea to use it. Then I will talk about the way you can use it in graduate research, and I'm going to give you a clear example of its use. Let's begin by discussing what big data is, because you cannot use what you don't understand, right? Here you have three basic definitions of big data. The words in black highlight main aspects of it. We can say that big data is a term that describes the large volume of data, both structured and unstructured, that inundates the world on a day-to-day basis. But you know what? It's not the amount of data that is important. It's what we do with the data what really matters. It can be analyzed from insights that lead to better decisions and strategic moves, and that is its principal goal. As we said before, we commit ourselves to analyze information in order to solve problems and improve life. You need the action. Not only have to have large numbers of things, but the real thing is, what are you expected to do with that data? Concisely, the term big data refers to data that is so large, fast, or complex that it is difficult or nearly impossible to process using traditional methods. The act of accessing and storing large amounts of information for analytics is not new. No, not at all. But the concept of big data became well known in the early 2000s when industry analyst Doug Laney articulated the now mainstream definition of big data as the three V's. V's. Volume. Organizations collect data from a variety of sources, including business transactions, smart Internet of Things devices, industrial equipment, video, social media, and much more. In the past, storing it would have been a problem, but cheaper storage on platforms like data lakes and Hadoop have eased the burden. By the way, Hadoop is an open source software framework for storing data and running applications on clusters of commodity hardware. It provides massive storage of any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. For some organizations, the amount of information may be tons of terabytes of data or even hundreds of petabytes. You know what a petabyte is? Petabytes holds 1024 terabytes. And if you want to store that amount of data at home, you will need 1,000 large home computers. So now you have a good idea of the volume of data that big data deals with. Velocity. With the growth of the Internet of Things, data is generated at an unprecedented speed and must be handled in a timely manner. Radio frequency identifications, tags, sensors, and smart meters are driving the need to deal with these torrents of data in near real time. And the most challenging point is not to gather the information, but to act on it. Welcome, Geronimo, and come up. Now, the last basic V is variety. Data comes in all types of formats, from structured numeric data in traditional databases to unstructured text documents, emails, videos, audios, stock ticker data, and financial transactions to mixed formats. The unstructured data require additional pre-processing to derive meaning and support metadata. There are some terms here that are difficult to pronounce for a non-native speaker. Okay, but the three basic V's have been complemented with another three V's: veracity, value, and variability. Veracity refers to the quality of data. Because data comes from so many different sources, it's difficult to link, match, cleanse, and transform data across systems. Organizations need to connect and correlate relationships, hierarchies, and multiple data linkages. Otherwise, their data can quickly spiral out of control. Value. Data has intrinsic value, but it is of no use until that value is discovered. Finding value in big data isn't only about analyzing it. is an entire discovery process that requires asking the right questions, recognizing patterns, making informed assumptions, and predicting behavior. And variability, in addition to the increasing velocities and varieties of data flows are unpredictable, changing often and varying greatly, like most of things in today's world. That's challenging. But organizations need to know when something is trending in social media and how to manage daily, seasonal, and event-trigger peak data loads. Okay, now I think you have a more understandable idea of what big data is. Of course, that's not enough, but that idea is well illustrated in this quote because it sets up the context from which big data emerges and let us foresee the potential that committing to gather, analyze, and use the resulted information may have for our present and future. Once again, it's not a matter of having tons, terabytes, petabytes of information. It's a matter of using it for make life better. Why is big data important? That's a question that you may be asking, because it's something that we are not so used to, but that each day is getting is becoming more important for all of us. And let's see why. The three main reasons because big data is so important and efficient are cost reduction. Big data technologies such as Hadoop and cloud-based analytics bring significant cost advantages when it comes to storing large amounts of data. So you don't have to pay big amounts of money for having this data available for you to analyze. Another reason for its importance is that big data is faster, help you to have faster and better decision making. With the speed of Hadoop and in-memory analytics, combined with the ability to analyze new sources of data, organizations are able to analyze information immediately and make decisions based on what they've learned. You know that today's world is so uncertain and changing that you cannot afford to spend a lot of time making a decision. You need to make a decision that can be implemented as soon as possible before the context changes. And that's what you can do when you analyze big data. The third reason for being so important is that you can have new products and services. With the ability to estimate people's needs and satisfaction through analytics comes the power to give them what they want or need. The importance of big data doesn't depend on how much data you have, but what you do with it. You can take data from any source and analyze it to find answers that enable, first, cost reductions, second, time reductions, third, new product development and optimized offerings, and even, number four, smart decision making. When you combine big data with high-powered analytics, you can accomplish organization-related tasks such as, for instance, determine root causes of failures, issues, and defect in near real time. So you know why something is not working very, very fast. Generating tasks and rewards based on people's habits. You can know what the habits of people are, and then you produce something that can give you a kind of advantage in relation to those habits. It's when they give you a coupon, or they give you an award, or they give you an opportunity to have a reduced price, that kind of things. And also, organization use big data for detecting and recalculating risk of decisions in minutes. Imagine if you make a decision in such a changing world, and then you have to spend a lot of time before you realize that you made the wrong decision. Now, using big data, you can avoid such a mistake, okay, and do things better. All these reasons and many others help us understand why research using big data can be significant for our context. Now, regarding the benefits that big data may have by creating more and best paid jobs opportunities, we can say that it is a fast-growing field with exciting opportunity for professionals in all industries and across the globe. Big data has a significant impact on the way, for instance, candidates look for jobs, as well as how employers make hiring decisions. Why? For example, for job applicants, big data is useful to know the inner characteristic of a company, like its culture, political preferences, salaries, management style, etc. So you can know the organization even before applying for a position. Organizations can use big data to set and evaluate hiring goals. What kind of employee I really need? Using a combination of these in the recruiting process, they can mitigate the risk of poor hiring practices. Today, many analytics tools exist to measure candidates on various factors like personality traits and cognitive capabilities. These are ranked in accordance with key performance indicators that a company considers essential for success. Yes, Sadia, you are going to receive the link for this recording, or the recording of this webinar. Don't worry. And believe me, I know that you will need to listen to this more than once in order to really to realize the power that is in big data and all the things that you can do with big data. Now, let's have a look at when you need big data, because you may say, okay, it seems to be very useful, but when can I need it, or when can I use it? Okay, well, let's have some examples, in fact. So to know when you need big data, let's have a look at 6 areas where big data is being used to make better and more timely decisions. Let's begin with big data in banking. Banks are making use of big data in big ways, from boosting cybersecurity to cultivating customer loyalty through innovative and personalized offerings that make modern banking a highly individualized experience. It's like education for all, which is individualized. It's created for each individual. It's the same with banks. Banks can better understand customers' financial behavior and anticipate future needs to offer tailored products and services. And they can learn a customer preferred channel of communication, such as mobile alerts or emails or traditional paper correspondence. So, if you are interested in researching about financial organizations and policies, big data may help you. So remember that this webinar is trying to connect big data to your research. And that's why I'm going to connect each one of these areas to possible research studies. So if you are in administrative and business administration, for example, and you want to research financial issues, take care and pay attention to big data. The next area is big data in technology, which seems to be, the most direct area for big data. Big data trends and emerging technologies include self-service data preparation, the cloud, Internet of Things, data as a service, and embedded analytics. As the amount of data grows from sensors, click streams, and social media, organizations often turn to new technologies to capture and analyze that data for their insight. Imagine the amount of information that organizations can have just each time one of us click a button in our telephones or on our computers. So by turning that raw data into organization opportunity, that thing is tricky. And several big data trends and emerging technologies have been identified to do that, like self-service data preparation, for instance, or taking things to the cloud, etc. So if you are interested in investigating how to transform big data into useful information, you will go into this area. If you are engineer, if you are studying engineering or something like, or technology or computer sciences and so on. Now, big data in customer service and marketing. Responding quickly is critical for reducing negative customer experiences as well as promoting more positive ones. And the only way to do this efficiently with the volume of interaction occurring is by using big data. With big data, companies can easily track negative remarks and respond to customer problems. Plus, big data from social media activity can provide huge insights into customer concerns and enable your company to identify and fix customer service issues quickly. Because when something is wrong for your customer, the sooner you address it and make it better, the fewer customer you will lose. In marketing, big data is providing insights into which content is the most effective at each stage of a cycle, for instance, a sales cycle, or how investment in customer relationship manager system can be improved, or in addition to strategies for increasing conversion rates, prospect engagement, revenue, and customer lifetime value. So if you are interested in how businesses can improve the responses to customers and their sales, big data will help you. Big data in manufacturing. Big data solutions aim at predictive maintenance and predictive quality are good examples of how manufacturers are using data to optimize performance and related operations. Okay, you create or you buy a machine, but it's not only that, it's how you can predict the function or the way that machine can function better, how you can make their performance better, how you can create related operation to take advantage of your investment in that machine. So innovative manufacturers are using big data technologies to focus simultaneously on customers and operation. If you are interested in improving manufacturing procedures and results, look at big data as your main source of information. And this is the one that I love, big data in education. Of course, because I'm a teacher. So there is an increase in the number of studies that address big data in education during the last 3 years. It has been found that the current studies cover 4 main research themes under big data in education, mainly learners' behavior and performance, even in standardized exams, for instance, or in any kind of performance. Modeling and education data warehouse. Improvement in the educational system, especially in the curriculums. And integration of big data into the curriculum. Okay? So 4 sectors are very likely to benefit from big data. Which ones? Improve students' results, customize programs, reduce dropouts, and target international recruits. 4 very important areas regarding education. In the academic setting, we envision classrooms fitted with continuous video feeds that capture intricate details of learning. For instance, facial expression, discrete physical movements, and social interaction. Of course, you can think of that we are asking for a big brother in our classrooms. Yes, but yes, in the sense that you can know how to improve education, not that you can use that information, that use data to being prescriptive or to apply not well-desired consequences for what you are doing. But that part, like with any human creation, is a matter of ethics rather than a matter of the technology. It's a matter of ethics. That's different. But this technology could capture every item that the students interact with and every statement made by learners and educators. And if I have this technology in one of my usual classroom, perhaps I will be I will lose my job because I'm usually politically incorrect. Additionally, the evaluative system could incorporate biometric signals recorded by wearable devices like watches, smart watches, right? Allowing researchers to discover what drives learning and positively motivates students. And this is another aspect of this. If you are an educational researcher, you may want to know by means of biometrical signals how a student react to a specific method or technique. And in that way, you can have information enough to say to teachers and to educational authorities, if you use these kind of techniques, you will have better results from students' performance because when they use it, they are relaxed. And it will not only be a matter of saying that the teacher think that the student is relaxed, but because you have the measures of the stress indicators. So therefore, big data technology holds amazing potential for the future of teaching and learning. And in the present, you can use it to propose innovative research studies. And big data in social service and governance. Big data is being used for social good in areas like crime prediction, impact of flows, social economic level inferences, homelessness, human trafficking, weather impact, etc. Governments can use big data to transform their procedures, actions, and decisions in service delivery, policy making, and citizen engagement. So if you are a social researcher, this could be a very good source of information for you. So imagine how useful can be big data for you if you are interested in social and government issues. The third part of this webinar is devoted to give you a good idea of how you can use big data in your research. Let's begin by discussing the kind of problems that may be suitable to use big data as the source of information. So, Adrian, hello. So now that you have a good idea of what big data is, now let's check with what kind of problems you can use that. Here you have a small example of research studies done by graduate students using big data. That is the link for that complete list, and you have it in the description of the webinar and there too. So, hello, my dear. One element, if you look at this title, one element that is present in problems whose interpretation can be addressed by means of using big data is the demand to know hidden patterns and trends. That's what we're looking for. Patterns and trends that we cannot see at first sight. So we need to work with lots of information in order to recognize them. And for instance, trends of hidden patterns are discovering consumer shopping habits, personalized marketing, fuel optimization tool for the transportation industry, monitoring health condition through data from wearables. Whenever my Apple Watch says, take care with this, and this is your heart rate and so on, imagine how useful that data is. Live road mapping for vehicles and autonomous vehicles, streamlined median streaming, predictive inventory ordering, personalized health plans for cancer patients, real-time monitoring and cybersecurity protocols, predicting students' performance in their careers, and many, many, many other ones. Now, those examples illustrate some of the types of big data analytics you can use when understanding and solving research problems. But let's have a look at that. Here you have 5 types of big data analytics. Prescriptive analytics. It gives you a clear and accurate focus to answer a specific question. It helps to determine the best solution among a variety of choices, given the known parameters, and suggests options for how to take advantage of a future opportunity or mitigate a future risk. It can also illustrate the implications of each decision to improve decision making. Examples of key points in the problem that may benefit from prescriptive analytics are: if your problem requires you to look forward because you have to predict something, or focus on optimal decision for future situations, or simple rules to complex models that are applied on an automated or programmatic basis, or discrete prediction of human data set members based on similarities and differences, or optimization and decision rules for future events. When you need that, you can look for prescriptive analytics. Diagnostic analytics. Researchers turn to this technique when trying to determine why something happened. It is useful when researching leading indicators and usual trends amongst your population. You have a population and you want to know, let me see if I can understand why they behave the way that they did, why they did that. Example of key points in the problem that may require diagnostic analytics are when you have to look backwards, when you are focused on causal relationships and sequences, or on relative ranking of dimensions of variables based on explanatory power, or target or dependent variable with independent variables and dimension. When you have many independent dimensional, lots of complex interrelationship among variables, or when includes both frequent and Bayesian causal information analysis, when you are looking for cause-effect relationships in a big population. Descriptive analytics. This is useful for uncovering patterns within a certain segment of subjects. Not the entire population, but a part of that population. Descriptive analytics provide insight into what has happened historically and will provide you with trends to dig into more detail. Examples of key points in the problem that may benefit from descriptive analytics are: focus on description and comparisons. If you are interested in establishing description and comparing things, pattern detection and description, or mutual, exclusive, and collectively exhaustive categorization, NECE. Category development based on similarities and differences, which is called segmentation. Predictive analytics. It uses models to forecast what might happen in specific scenarios. Examples of its key points include, of course, looking forward, focus on non-discrete prediction of future states, relationship, and patterns. And look at this, non-discrete predictions is something that you want to do, but that you cannot foresee how to separate it at first sight. Description of prediction results and probability distribution and likelihood. Model application. Non-discrete forecasting. In other words, forecasts communicated in probability distributions. Outcome analytics is the last one. It provides insight into population behavior that drives specific outcomes. This analysis is meant to help you know your population better and learn how they are interacting with the main elements of the research problem. Its key points are backward-looking, real-time, and also forward-looking. So three different types of lookings. Focus on consumption patterns and associated business outcomes. Description of usual thresholds, and model application. So if you are interested in any of these analytics, then big data can be a great source of information. Now, let's have a brief look, because we cannot do too much in this sense, but let's have a brief look at some widely used big data techniques. Look, A and B testing. This data analysis technique involves comparing a control group with a variety of test groups. You are familiar with that, but imagine that the test groups are more than 20 or 30 or hundreds, how complex that can be. So when you are interested in comparing control group with a variety of test group in order to discern what treatments or changes will improve a given objective variable, big data and this technique, A/B testing, is your guide. Big data fits into this model as it can test huge numbers. However, it can only be achieved if the groups are a big enough size to gain meaningful differences. So it's not to be used if your groups have 10 people or 10 items. No, you need lots of subjects or items. Data fusion and data integration. By combining a set of techniques that analyze and integrate data from multiple sources and solutions, the insights are more efficient and potentially more accurate than if developed through a single source of data. And the other one, data mining. is a common tool used within big data analytics. It extracts patterns from large data sets by combining methods from statistics and machine learning within database management. An example would be when data is mined to determine which segments are more likely to react to a specific thing or action. These two, data fusion, data integration, and data mining, are so important and are so used that there are people who are hired only to do that. So you can have a job which is you are a data miner. So you have to go into large data sets, and look for hidden patterns, and that's your job. Or you can be the person who does data fusion and data integration in an organization, because you have to combine different sources of data. So a job is related to that. Machine learning is well known within the field of artificial intelligence. Machine learning is also used for data analysis. Emerging from computer science, it works with computer algorithms to produce assumptions based on data. It provides predictions that would be impossible for human analysts. And the next one is especially for my friend Adrian. Natural language processing, known as a subspecialty of computer science, artificial intelligence, and linguistics, this data analysis tool uses algorithms to analyze human natural language. Sadia, did you register for this webinar? If you did it, you are going to receive the recording link. Okay? And finally, statistics. This technique works to collect, organize, and interpret data within service and experiment. By the way, if you didn't register for it, you can still register and receive the recording link. So there are other data analysis techniques like spatial analysis, predictive modeling, association rule learning, network analysis, etc. But this is just a small selection just to illustrate the point. Now, I will present you some tools that are used to extract, to analyze, and interpret information from big data. Here you have tools of 5 different kinds that are used when dealing with big data. I encourage you to deepen of those that you think may be a good option for your research. In the example of using big data for a graduate research study that I'm going to present in the next section of the webinar, you will see some of them mentioned, okay? So you have tools that are open source data, you have tool for data visualization, tool for work with sentiments and emotions, tool for extract data, and databases. Okay, you have more of them, more of these ones, but these are very, very used. Well, it's time to see the application of what I have talked about today to an actual study. Let's see it in a study. This example was taken from the proquest list of a study mentioned before. Since it is not easy to read this information, I'm going to present it separately. And here you have the study and author information. check the title and try to connect it to what we have talked about so far. Okay? Let's see the abstract. This is the abstract. The information in black gives you hints about why big data was chosen as source of information. Okay? Look, this person worked with information taken from Twitter. And that means that the information has to be served within 5.7 million tweets, for instance, and uses global data. The location of the organization development tweet writers are compared with the location of those who tweet about other management and organizational study topics. So there was a interconnection in different parts of the world. And she uses two different types of analysis because she uses qualitative analysis, grounded theory approach for social network analysis, but she also used the quantitative analysis of the data. I choose this one because I think it is very complete in that sense. Now let's check the methodology, the purpose. Here you have the purpose that guides the research and the research questions that are expected to provide information to achieve that purpose statement. So the purpose of the research was to explore the impact of organization development using contemporary large data sets. So, of course, there are lots of information about organization development, but how many studies have been done so far in which data is contemporary, is today's data, and it's presented in large, huge data sets? Okay? And those are the research question that has been associated to this study. Now, this is the methodology. Look, how this person, she says that analyzed tweets using qualitative method, and then did a quantitative analysis to look at the relationship between the coded networks. It is complex. It is huge, okay? Of course, you once you have the recording, and please remember that you have the handout under the handouts tab, and it is going to be sent to each person who registered for this webinar. There you can check all these little details better, and of course you can go into ProQuest and download the whole study. And here you have, that's the way, that's why the tools in blank font were used. Reflect upon the complexity that the interconnection of information implies. Here you have data mining, one of the techniques that we talk about. Python computer program, well, we don't talk about that one, but oh yes, it is over there. SPSS, but Node XL is on the tools, and Google Fusion Tables is on the tool too. So 1, 2, 3, 4, 5 different tools used to analyze, to extract information from such a large database. Okay? And look, you can realize all of that in this graph. It's taken from the study. You can check the whole study going to the link of proquest provided in the slide 22. But look how 500 million tweets per 10 days, which means 5 billion tweets. How can you analyze that using traditional method? You can't. But how important and useful information you can get from that, wow, it is incredible, really. Okay. Then she uses Python program select tweet, select all the hashtag and other related network. So it was a kind of filter. Tweet for 7 to 10 days in CSV format was taken to SPSS, eliminate duplicates, then go to tweets without duplicates, and use Google Fusion software to create a word map with location of tweet writers, and then SPSS code user by network, to then get to summary by user, to then get to NoXL software to create the social network relationship information. Isn't it amazing? Isn't it interesting? Well, read that study to know what she recommend to do with her results. Okay, to finish, I have to say the new times and context produce new information. And right now, that information is generated in a way and a speed never experienced before. Therefore, the problems associated to such a new environment cannot be identified using traditional methods. That's why graduate students like you may need to turn to big data as the source of information. Well, I hope this information, with all those strange terms that have make a twist in my tongue, can help you at least have a basic but useful view of what you may be dealing with. So thank you. Okay, Gemma says, I have another meeting at noon, so I have to go. Thank you. Okay, don't worry. You will have the recording, and I continue recording if there are any kind of questions right now. Bye. Thank you for coming. Any question, anything that you want an explanation or something like that? Or was it too overwhelming that you need? I know that you will need time to process all these things, but could you tell me if you think it was interesting for you? Can you foresee a kind of use for these things? Nope. Well, if Adrian is so silent, I'm really, really worried. Oh, Alien said, brilliant, Maria. Well constructed and presented. Very informative and short. I love it. Oh, thanks God. John, yes, very interesting and useful information. And Brandon, yes, very interesting. I'm just starting to learn about big data, but love it so far. Me too, Brandon. I don't know what I'm going to do with it, but I want to learn about it in order, if I cannot use it by myself, at least to help other people. And that was my intention today. It was to give you a concise but clear idea of what it is, what big data is, what it can be used for. Of course, you have to reflect upon that, and you need to find specific parts of your research in which you can use it, if you can use it. I mean, but I think it's a very interesting and promising area. And that's why I specifically chose that example. Because when I look at this and say, how can you get to this? Oh my God. Mario says, yes, wonderful information gives a great starting point on how to create a portfolio of research work. Thank you, giving your time. Yeah, I agree with you, Mario, and that was my intention, that you have a starting point. And from that point, you can create and you can have many opportunities to do things. Imagine this, a social network relating to organization development, creating from 5 billion tweets. How can you do that? Okay, and the number of different options that you have for working with open source data, or look at, I want to surf these sentiment tools. How can you use these tools in order to surf, to go to mind emotions and sentiments of subjects? Wow. Of course, as I said before, ethical issues are behind these things, but it is not a product or an effect of the technology. It's a matter of how we human beings use the tools. What for? And that's why from the beginning, I told you that it's not a matter of having the information, is what you do with that information to make life better. Okay? The data visualization tools is great. But Google Fusion tables, for instance, and that you can in one table have the most important aspects of a problem and its solution, and that you can have a job doing these things. Is amazing too. I'm going to stop the recording, not before saying thank you to all the people that register for this webinar, but especially for the people who came and here and be with me for some time. Thank you.